In this presentation, we're going to be talking about chimneys and draft with respect to oil furnaces. Draft is probably one of the most important things that you can have in an oil furnace, and it is also one that is in part controllable by you, and in part controllable by the contractor that built the building, and in part controllable by nature. So there's three paths that exist here, but basically draft is proving that there's a path that exists to remove combustion gases from the house. You can't change the design of the chimney under most cases, but you have to be able to get the best efficiency under all conditions. So when you're looking at this picture, draft is anything where there is a path straight up to the outside world from an inside of a building. We have to remember, by default, hot air rises. Okay, it's created by natural air currents where the heat rises out of the chimney and the cold air comes in, or cooler air comes in to replace the air that's removed. Okay, chimneys are not smart things. They don't know that they're supposed to draft up. They don't know they're supposed to be removing the carbon monoxide and other combustible results from the building or the products of combustion, but they do know that it is a straight path to the outside world. So draft that is created by heat is known as thermal draft. So again, back on this picture here, I have a burner inside a furnace. I'm creating the draft by the heat. That's known as thermal draft. If it's created by air patterns or air currents, it's natural draft. So the air currents hitting the side of the house and moving air in and out of the house, that's natural draft. Wind blowing across a chimney, so across this top of the chimney, that's called current draft. Okay, now I can actually control draft a little bit by adding a fan or a blower to a flue pipe. Okay, here's an example of that. I can add a blower motor with a housing to the bottom or side of a flue pipe, and I can cause and help boost draft. The boost draft handles all combustion gases and it forces it out of the building. However, that's not the ideal way to do it. Okay, because eventually those things go bad. Here's just a picture that a home inspector took of a draft inducer motor added to. That is one big flue pipe for that size furnace and that size. So it is likely that this whole chimney has a bad draft situation. Someone did try to fix it with a draft inducer motor. Was it done correctly? Probably not. Okay, so we have to have a slight vacuum present in the combustion area. Without the vacuum, the flame will pulsate and rumble, and also it will eventually overheat. Anytime you see rust, like this type of rust you see on the front of this furnace picture here, dripping down from the flue pipe, that is a sign of not having correct draft. There's nothing else wrong here, and probably someone just searched the whole thing and tried to figure out what was going on. But the bottom line is, rust here, rust lines running down from the flue pipe, there's not enough draft. Draft is measured in inches of water column. 1 inch water column is the pressure difference required to lift a column of water 1 inch. This is an example of a draft gauge that is used most frequently in the oil industry. Now, to the left is not negative. To the left is positive, and then you go to a negative draft. Okay, 1 psi is 27.7 inches of water column. It's a number you need to know. Typical oil draft should be a negative 0.04 to a negative 0.05. Sometimes you'll take a 0.02, but you don't want to go there. Again, negative is because the inside of the flue pipe is at a vacuum compared to the outside room. We want to make sure we keep the products of combustion inside the space of the flue pipe. Okay, we measure draft by using a draft gauge. Okay, it's a negative pressure. It's a pulling force over the fire. So this flue draft, this heated draft that's caused by the heated air getting into the chimney, it pulls new cold air in. So we always have a constant flow of air into the furnace, up the chimney, and out to the outside environment. Okay. If a positive pressure exists, no venting is taking place, and sometimes it gets bad enough that we start following the red arrows here, and we can actually pull air from the outside coming down the stack. Now what that does, it pulls the products of combustion like carbon monoxide and all the other gases into the space. It's a very dangerous condition. So one of the most important measurements you as a technician can take is to make sure that that chimney is in a negative draft. Okay, combustion gases are hotter than the outside air. Hotter means lighter. Lighter means automatic rising up the chimney, resulting in suction over the fire. So what this technician is doing here, he's using his draft gauge, and he's going to be taking a reading over the fire. Okay, and it's just done right at the access door. Every oil furnace has a spot to take an over the fire draft. Now, there's determining factors involved here. Okay, 1 CFM of air at 60 degrees does not move as fast or rise compared with 1 cubic foot of air at 600 degrees. You also have chimney height. So the higher the chimney, the greater the draft. So we have the determining factors of temperature of the air and the chimney height. Okay, hot gases, hotter chimney equals increased draft. Now, you have to deal with this factor because on weather changes, okay, on cold days you'll have a greater draft. So midwinter your draft may be excellent, okay, because there's a greater difference between the chimney and outside air. But for those people who use an oil furnace or oil burner in the summer months to like heat hot water, you could have a very low draft if on a 90-degree day where the boiler's running to heat hot water. So the less temperature difference between the chimney and the outside air, the lower the draft. So again, as the temperature difference increases between your inside and outside environment, or the inside flue temperature and the outside air, the better your draft is going to be. Okay. The chimney is a permanent structure. We consider it to be a constant. Your variables are the temperature of the flue gas and the outdoor temperature. Those variables are constantly changing. Outdoor temperature is beyond our control. Temperature of the flue gas I can control. Okay, so I can adjust that by the addition or removal of combustion air. Every time you change a burner adjustment, you affect the draft. Chimneys must be warm and dry. They have to extend 2 feet above the surrounding objects. They also have to be vertical and straight. Since the chimney is cool at startup, the draft will increase as the temperature rises. Okay, and this will vary. Over a year's operation, the draft may be a low of 0.02 and a high of 0.014. Now, if you think about it, probably, or you may have heard of, the experience of a fireplace starting. When a fireplace first starts up, it's relatively smoky. Some people open some windows around when you first start a fireplace to allow cool air in. That's to help create that initial draft. Or you can actually have smoke coming the wrong way out of a fireplace. Change in draft regulation is not wanted. What we want is a constant draft. Okay? If the draft is continually changes, you will have smoke change, you'll have reduced efficiency, you could have a high draft that's shut off, which means more heat is being pulled up the chimney and you have heat loss. And again, this picture here, you'll notice some rust, you'll notice debris around here. Okay, this is a picture of poor draft. We want to vary the draft to compensate for changes. A drop in draft affects airflow into the chamber. After proper draft is obtained, the supply air is set. Okay, an overfire draft should be a negative 0.01 to a negative 0.02. And this chart here actually shows you what the recommended from most of the manufacturers' drafts are. Okay, so for a conventional oil burner, we want a negative 0.01 to a negative 0.02 water column. For an oil burner with flame retention, that's a much tighter flame, you can actually drop that to a negative 0.005 to a negative 0.02. The stack draft, which is taken above the furnace or boiler, we really want a negative 0.02 to a negative 0.04. You'll notice in that range. I really like to see a negative 0.03 to a negative 0.04. And again, that's all adjusted using the draft adjustments on the draft regulators. Okay, you'll also see draft regulators referred to as a bypass air bleed. Okay, it uses a swinging door with a weight. And if you look at the pictures here, you see a swinging door with an adjustable weight. As the door opens, room air mixes in with the flue exhaust, and it cools the stack gas temperature by lowering draft and reducing the pressure by allowing air to enter. So the more this door is open, the less draft you're pulling through the furnace because you're actually bypassing it by adding room air. Now just be aware there's different types of draft controls. You have to check code and you have to look at the equipment to make sure you have the correct one. The door opens and closes due to changes in room and chimney pressures. So that's why the weight is there. Okay, the proper name for it is a barometric draft regulator. A draft regulator can only reduce over the fire draft. It cannot increase draft. So if you have low draft to start with before adding a barometric regulator, you don't have a chance of getting that draft up. You've got to fix the draft problem first. Okay. The way to measure and adjust it is use a draft gauge. We check for over the fire draft, and the shaft must be horizontal and the door must be free. We also want to operate the burner for a minimum of 5 minutes before we check the draft, and that's to make sure that our chimney is warm. Now, you might occasionally see homeowners do funky things to keep that draft door closed to try to increase draft. It's not a good idea. That door has to swing free. You have to be able to push on it with a finger and open the door and let it release. The lowest possible level of over the fire draft is a negative 0.01 to an 0.02. If over, adjust regulator, counterweight to keep open. Okay, if so, in other words, if your draft is too high, so if you was reading a 0.05 over the fire, open that counterweight, adjust the counterweight on the draft regulator door to open that door a little bit. Okay, you might have to add a second regulator also. If below, okay, if your draft is too low, you want to close the counterweight to slightly close the door. So it's all done with that counterweight on that draft regulator. The draft in the stack needs to be greater than the over for the fire. It's a negative 0.02 to a negative 0.04. Normally, we want a 03 to 06. You want to try for right in the middle. 05 is good, 04 is good. If the stack draft is too high, there's an indication of a dirty heat exchanger. Soot will build up. Okay, as a dirty heat exchanger, it increases restrictions, air delivery falls off, and smoke is the end of the result. If the draft is too low, this is indication of a restriction in the chimney someplace. So the draft regulator has to be installed in certain locations. Okay, this is a great chart of where to put it. It needs to be between the furnace and the chimney. Okay, should be after any elbows. Needs to be on a straight piece, and the draft regulator must be level. Okay, the crossbar in the draft regulator door has to be at horizontal in line with the floor, and it has to swing freely. You cannot put it on the top or bottom of pipe. You should not put it on an end of a T. Okay, and you should not put it at an area lower than the furnace or boiler. Okay, 1 square inch of chimney size for every 16,500 BTUs of input. Now check local codes because that's a rule of thumb. Your local codes may be a little bit different. The stack size has to be the same size as the unit collar. In other words, if the collar coming out of the furnace is a 12-inch collar, you cannot go down to a 10-inch or 8-inch pipe. Okay. Rule of thumb for stack sizes, and again, different manufacturers have different things on their furnaces, but 6-inch for under 1.0 GPH, 7-inch up to 1.5, 8-inch, okay, goes from under 1.5 to 2.5 gallons per hour. Again, that is a rule of thumb, but you have to have 1 square inch for every 16,500 BTUs of input, okay? Remember, 1 gallon of oil, 140,000 BTUs. You want to keep the stacks as short as possible. You want to keep it in uniform sizes. You want to use 45s instead of 90s. Okay, 45s have a less bend. You have to firmly use 3 sections. You have to install all sections with 3 screws and cement over all holes, even at the chimney. You cannot make up your own draft material using flexible pipe. That's not allowed. Okay, the draft regulator mounts between the chimney and the stack control. Okay, it's a minimum of 18 inches from any controls in the draft. Okay, if there's no controls, you have to have 18 inches from the furnace. Okay, it should be 10 inches larger than the stack. So back to just summarize. Okay, draft is one of the most important measurements you take. You have to take draft readings at each furnace cleaning. You have to take draft readings anytime you do any adjustments to the burner or the chimney. Or if there's any suspicion of downdrafting or backdrafting, look for rust on the furnace, look for rust on the flue piping, and double check and make sure that flue piping is not rotting away from the inside out. If you have draft in the chimney, you will usually have a proper fire. You will not have carbon monoxide. You will not have soot issues.